Hello Math 3A and welcome to some examples that I'm going to do that are just like problem set number 1. So in fact, here are some of the problems that I'm going to do circled in red. So this limit, this one that's got some fractions, something like this where you need to multiply it out. And something else that I wanted to point out is, as a part of this class, you are going to be doing the podcast problems where I've created 2 examples from each section and recorded videos, which you could watch at the YouTube channel right there. And if you look through these, you'll find out that there's examples very similar to what's on the problem sets as well. So in case I don't cover everything you need in this video, then you can go to the podcast problems and you'll find examples very much like what are on problem set number 1. Okay, then to get to the examples. So this is like number 2. It's actually like number 1 as well. And the idea is that if you take a 3 and substitute it in, this is going to cause division by 0. So that means that we need to do some algebra, and the algebra that we need to do is factor. So this numerator right here can be factored. Not only that, x minus 3 has to be a factor because this is causing division by 0 and we need it to cancel. So not only can the top be factored, but x minus 3 should be one of the factors. Let's see if it works. So in order to get a 2x squared, I would need a 2x. And then in order to get a 21, that would be 3 times 7. And since this is a negative times this is supposed to be a negative 21, this should be a positive. And then if I just double check the middle term, this would be negative 6x, and this would be a positive 7x, which leaves behind a positive x, so it worked. And so basically with this limit, this is 0. Actually, when you plug in 3, it's 0 divided by 0, but because x minus 3 is showing up in the top and the bottom, you can use your red pen and just cancel those. All that's left is 2x plus 7, so then when you substitute 3, that's going to be 6 plus 7, so that's 13. And then just real quick, I can check the answer by using a calculator. Of course, the point is that you do show all of the work, but then you can use a calculator to check it. So if you were to go back to the original problem and say I've got a 2x squared plus x minus 21 that's divided by x minus 3. And then this was the limit as x approaches 3, so I need to see what's happening at 3. Okay, so the answer was 13 and my graph is only going up to 10. So I need to change the window, have it go up to at least 13. So, this part was fine. It's the y value that needs to go up to at least 13. I'll go to 15. And then you'll see if I trace and I plug in a 3, it says there's nothing there because that's the division by 0. But if you put something close to 3, like 2.999, then it should say 13. 13. So now it deserves a red check mark because that is correct. And then for the next one, which is similar to number 3 on the problem set, because it's got a fraction, 1 over x. And then specifically, we're going to find the limit as x approaches a for f of x minus f of a over x minus a. So this one is actually sort of a combination of number 3 and there it is, and number 7, because number 7 also has a fraction, and it has this, which is the definition of the derivative. One of the most important ideas in calculus, the definition of the derivative. Okay, so this is going to be take the limit as x approaches a And this will be 1 over x, and this will be 1 over a. And then just copy down x minus a on the bottom. And because this is a compound fraction, what I'm going to do is simplify it. So take the common denominator here. So with an x and an a, the common denominator is x times a, or a times x, whichever you prefer. And then multiply on the top and the bottom by x times a. So then simplify. So when you multiply this and distribute, the x is going to cancel. It only leaves an a. And when you distribute here, then the a's are going to cancel. It's going to leave behind minus an x. And on the bottom, just copy it down. Don't multiply it out. Because in a moment, this x minus a is going to get canceled. And that x minus a is what's causing division by 0, so it has to cancel. So if you notice, this is almost the same as x minus a. All I need to do is get the x to be positive and the a to be negative. So to do that, you could just multiply by a -1 on the top and multiply by -1 on the bottom. And then, showing all of the steps, that means that the top would have x minus a, and the bottom, I just recopy it. And then x minus a cancels x minus a, it leaves a 1 on the top. And then finally, x is becoming an a. So this x is going to become an a. So there's a 1 on top. There's a -1 on the bottom. This is an a times an a. So an a times an a is a squared. And that is the derivative of 1 over x. All right, next up. So there's two ways to look at the definition of the derivative. The last one I did was x approaches a. This is also finding the derivative, the limit as h becomes a 0. So this part means take x plus h and substitute it for x and substitute it for x. And then just write the function f of x. So this will be the limit as h approaches 0, and then put x plus h in place of x. So x plus h gets squared plus 7 times x plus h. All right, that takes care of this part. Now I need minus, and I should put it in parentheses or brackets because everything after this, the negative applies to it. And then you just put the f of x. X squared plus 7x. And then it's divided by h. Now since h is becoming a 0, this causes division by 0, so this has to be canceled. So we now need to do algebra. So square this. So I still need to write down the limit as h goes to 0. When you square a binomial, you square the first thing, x squared. Then multiply the two terms, x times h, and double that, plus 2 x times h. And then you square the h. Over here, just distribute the 7, so that's going to be plus 7x plus 7h. And over here, distribute the negative. Negative x squared minus 7x. And then there should be cancellation, like x squared and minus x squared, those are going to cancel. Positive 7x and negative 7x, those are going to cancel. And then notice what's left over. Every term has an h and an h. So what I'm going to do is factor out an h on the top. That will leave 2x. This will leave plus h. And this will leave plus 7. And now this thing that would be causing division by 0 is going to get canceled. So the h's cancel. And for the last part, the h can become a 0. So all that's left is 2x plus 7. And that, in fact, is the derivative, because the derivative of x squared is 2x, and the derivative of 7x is a 7. And if you're not sure how I'm doing that, well, in the next sections, we'll do the power rule, and we won't have to do this for the whole semester. So these limits are just at the beginning so that you understand the idea of limits, and that's where the definition of the derivative comes from. The next one I'm going to do is like number 6, because what if there's a square root? So when there's a square root plus something or a square root minus something, then use the conjugate. And the conjugate will be the same square root, the same number, but you change the sign. So this one's a minus, so this becomes a plus. If this happened to be a plus, then this one would have minus. And if you multiply the top by it, you need to multiply the bottom by it. And then multiply out the top. So when you distribute the square root of x times the square root of x, that's just going to be x. And the good thing about the conjugate is that the middle terms cancel. So this one times this would be a positive 10 square root of x, and this one times this would be minus 10 square root of x. They cancel. Then the last one times the last one will be negative 100, which is good news because the bottom has x minus 100. So for now, I'm just going to copy down the bottom without changing anything. And then the x minus 100 on the top and the bottom cancel, leaving only a 1 on the top. And now this is going to become the square root of 100. So there's a 1 on top, and then the square root of 100 plus 10. So this will be 10 plus 10. That means it's 1 over 20. And one last one for this little video right here. And that is this function continuous? So this is similar to number 9 on the problem set. So this is saying for the left side of the graph, use this, which is a parabola. So hopefully you've seen the x squared function before. If not, you can graph x squared plus 1 and then see that it's a parabola. But this part is saying only use to the left side of 0. So actually I'm only using this part. And that's crossing the y-axis at 1. So basically the left side of the graph looks like this. So you only use the left side of the parabola. And the right side is cosine. And cosine goes like this. It starts at the top, it goes down to the bottom, and then back up, and then that would be one cycle by the time you get to 2 pi. And then it would just keep going. And it happens to start at 1. So that means that the right side of the graph is cosine, so that looks like this. And then it oscillates up and down forever. And then, is it continuous? And the answer is yes, because there are no holes or gaps in the graph. So the answer is yes, it's continuous. So if it happened that the graph would have been like this, so let's say that the parabola part hits right here at 2, and then the cosine function would start right here at 1, then this is not continuous because it's got a gap right there. But this one does not have any gaps or holes in it, so yes, it is continuous.